Welcome back to our channel. So in today's session we'll discuss about one more concept in Dbms, that is joints. Okay. So first let us see how many types of joints, and then we'll see one by one with an example. So these joints are classified into two categories. One is inner join, and another one is a outer join. Right? So in this inner join, again it was classified into two categories. One is theta join, another one is natural join. And this outer join is classified into three categories: left outer join, right outer join, full outer join. So three categories. So this is usually, the join is represented as this symbol. This is a join representation. And coming to the theta join, so the representation will be like this, and here we have to specify the condition. And without condition, if you apply the join, that join we call it as a natural join, right? And left outer join, this is also similar. So this is the left outer join representation. Next, this is a right outer join, and this is a full outer join. Right? So these are the representation. These are the representation of this join operations. Right? So coming to the Venn diagrams, if you consider the Venn diagram, so this is a natural join. Actually, theta join will be represented as a Cartesian product. Okay, so in the previous session we have studied about the Cartesian product. So the same Cartesian product we can consider as a theta join, right? And see, left outer join, if you consider, so this will be the left outer join. This will be the left outer join. This will be the right outer join. This will be the full outer join, right? So that means, see, coming to the natural join, based upon the equal attributes, the two relations will be get joined, right? So coming to the left outer join, so it will consider all the records of a left relation and a common relation from the right relation, common tuples from the right relation. Similarly, right outer join, it will consider all the tuples of a right relation and common tuples from left relation. And full outer join, it will be having both the tuples of both the relations. Okay, both the relations. So this is the overview of join operations in relational algebra of Dbms. Now we will see one by one by taking an example, starting with the theta join. So here the two relations will be joined based upon the condition, right? So based upon the condition means, so any operator, any relational operator, we can give any relational operator, and we can relate, or we can compare two different attributes or one attribute with a value, right? Any type of condition, based upon any type of condition, if you want to join two relations, that will comes under this theta join. And the two relations joined with respect to the common attribute, so both the relations should have the common attribute. So with the help of, with respect to that common attribute, if two tables or two relations is being joined, that type of join we call it as a natural join, or sometimes we can also call it as equijoin, right? So we'll see one by one with a small example. See, let us take these two tables, a car model and a price, and Jeep model and a price, Jeep price and a car price. Okay, so here you can see, let us join. So let it be the relation name is C and relation name is J. So we have to find C theta join. So C dot price, let us take J dot price greater than C dot price of J. So we have to apply the theta join with this condition, J dot price greater than C dot price. So let us take this one. First let us consider the J dot price greater than C dot price. Consider the first one, 6,000, which is greater than 6 lakhs, which is greater than 4 lakhs. So there will be join with these terms. See, Jeep 1 6 lakhs, car 1 4 lakhs, right? So next, 6 lakhs greater than 5 lakhs. So J dot price greater than C dot price. So 6 lakhs is greater than 5 lakhs. So again there will be an join between Jeep 1 and car 2. So Jeep 1 with 6 lakhs associated with the car 2 with 5 lakhs. And 6 lakhs greater than 8 lakhs. No, it's not true. So these two tuples will not be joined. Coming to the second one, Jeep 2, 10 lakhs greater than 4 lakhs. Yes. So Jeep 2, 10 lakhs associated with a car 1 with a 4 lakhs. Next, 10 lakhs greater than 5 lakhs. Yes. So Jeep 2, 10 lakhs, car 2 with a 5 lakhs. 10 lakhs greater than 8 lakhs. True. Jeep 2, 10 lakhs, car 3 with 8 lakhs. So this is the relation, the resultant relation after doing this inner join, that is also a theta join, right? So this is Jeep model and this is a price, this one is a car model and this one is a price. So this is the relation, this one is the resultant relation after applying the theta join. So that means here the two relations will be get joined with respect to the condition, not with respect to the attributes, right? So here the two attributes of different, the attribute from different tables may not be equal, but the data type must be equal. Okay, so this is the theta join. So this is similar to our Cartesian product or cross product. Okay, so hope you understood this theta join. The next one is natural join. So for this natural join, we will consider one example and we will apply the natural join. So let us take these two tables as an example. A student table having the attributes the student ID, student name and the department ID. And coming to the second table, that is a department table which consists of department ID and the department name. So let it be S is the relation here and D is the name of the relation here, student and department. Now natural join. natural join. So here we are not supposed to give any condition. So based upon the similar attribute from the two tables, the join will be appeared. So relations will get joined with respect to common attribute. So from this common attribute we'll get the join, right? So here S join D, a natural join is, see, let us take all the tables. So SID, S name, department ID, D name. So we need not write the common attribute multiple times. Okay, the same attribute we need not write the multiple times, because in student table there is a department ID and in the department table there is a department ID. So we can combine both with respect to this department ID. So coming to this 101 with a department 1, right? So 101, the name is Raju and department ID is 1. Okay, so let us take here, okay, let us take one more, 4. Okay, so 101, some Raju with a department ID 1, which is CSE. Okay, next 102, so 2, there is a 2 here. So 102, Ravi, department ID is 2, what's the name? ECE. Then 103, so 103 with the department ID 1, yes, there is a department ID 1. So 103, some Ramu, department ID 1 and CSE, and 104, Hari with the department ID 3, the branch is AAA. So this is the join, this is the natural join. So the two relations will get joined with respect to the common attribute, right? So here the common attributes is department ID. So with respect to this common attribute, the relations will be get joined, right? So hope you understood this one. So that is called a natural join. The next one, outer joins. We'll see the outer joins. Outer join. So let us take an example. Yes, consider the same examples. So outer join, and in that first we will go with the left outer join. So left outer join means, yes, this is a relation for left outer join. This is a notation for left outer join. That means in the resultant we have to consider all the tuples of left relation, that means yes, and common tuples of D. So the result relation will have all the tuples or records or entities of S and common tuples of D. So first let us write here S ID, S name, D department ID, and then department name, right? So write down all the values: 101, 102, 103, 104. So let us take Raju, Ramu, Ravi, Ramu and Hari. So department ID, so 101, 1, 2, 1 and 3. And department name, see, 1, it's a CSE, 2, it is a ECE, 3, sorry, again 1, it's a CSE, and 3, it's a triple E. So if there is a one more name, some Suresh with a department 5, let us take, okay, let us take this one. So you have to consider one more 105, some Suresh with a department 5, but there is no details in the department table. So here we have to give it as a null. Here we have to give it as a null. So we have to consider all the tuples of relation S and what are the common attributes. So there are 1, 2, 1, 3. So 1, 2, 3 details are there. So we have to consider only this one, and we should not consider this 4, the last one, right? And for 105, it is associated with the department ID 5, which is not available in department name. So just pad it with null. Pad it with null. So we are giving all the tuples of S and a common tuples of D, right? So common tuples are 1, 2, 3 because there is no 4 and there is no 5 also. So we have given as a null, but 5 is available in S. So we have to write all the tuples of S. So we have written 105 also, right? So this is called a left outer join. So we have to consider all the tuples of the left hand side relation, and we have to consider only the common tuples of right hand side relation. And the next one, right outer join. So left is completed, right outer join. So for this we have to represent S, this one. So for this we have to consider all the tuples of right relation and common tuples of left relation. So the resultant relation will have all the tuples of D and common tuples of S. Common tuples of S. So consider, see, S, right outer join D. So you can consider S ID, S name, DPT ID and D name. So consider all the values of D, all the tuples of D. So first write down 1 CSE, 2 ECE, 3 triple E, 4 MEC. Now consider department 1. So 101 Raju, 102 Ravi, and again 1, right? Again 1. So consider 103 Ramu, right? Ramu, and this is also CSC. Next 104 Hari, 104 Hari, right? What about a 4? There is no association with the 4. So there are no values for department ID 4 in student ID and student name. Right? Hope you understood. So first write down all the tuples of department table. All the tuples of department table. Now write down the common tuples of yes. Right? Common tuples of yes. So there is association with department 1. So write down this tuple. There is association with the department 2. Write down this tuple. And there is again one more association with department 1. So add this one. And there is association with department 3. Write down. So there is no association with 5 in department ID. So you need not consider this one, because this is, yes, we have to write only the common tuples. What are the common thing? 1, 2 and 3. So here we are not having any association with the department 4. Any students who associated with the department 4. So that's why student ID and student name for department ID 4 will be kept null, will be padded with null. So similarly, which we have done in the left outer join also, left outer join, right? So here we have to consider all the tuples of right side relation and common tuples of left side relation, right? So this is how we have to apply the right outer join. So hope you understood this one. The next one is full outer join. Full outer join. Full outer join. So this is represented in this way. So we have to consider all the tuples of S and all the tuples of D. So let us write here yes ID, yes name, DEPT ID, D name. So write down 101 Raju, 102 Ravi, 2, 103 Ramu, 1, 104 Hari, 3, 105 Suresh, 5. So write down this one. D name. 1 means CSE, 2 means ECE, 3 means, sorry, again 1, so CSE, 3 means triple. So is there any relation with 5? No. So kept it as a null. Kept it as a null. Right? And there is no department ID 4. So insert 4 with mechanical. So there is no association with the students, any one of the student. So kept it as null here. Kept it as null here. So this is the full outer join of these two relations S and D. So this is nothing but the union operation of left outer join and the right outer join. So up to here it is a left outer join and this one is a right outer join. So we need to apply the union. So we have seen the union operation in the previous session, right? So once you refer that one, so the link will be in the description section. So the union operation, if you apply the union operation, it will combine all the tuples of both the relation and automatically the duplicates will be get deleted, right? So we'll get the same thing. So full outer join means all the tuples of relation S and all the tuples of relation D, and if there is no association, simply pad with null values. Pad with null values. So this is the full outer join, right? So hope you understood this join operations. So two categories of joins, inner join and outer join, and in the inner join the theta join based upon the condition. So the tuples will be joined with respect to the condition given, and the next one is a natural join. So two relations will be joined with respect to the common attribute, and the outer joins, the left outer join, we have to consider all the tuples of left side relation and common tuples of right side relation, and right outer join we have to consider all the tuples of right relation and common tuples of left side relation. And coming to the full outer join, we have to consider all the tuples of left side relation and right side relation, and also simply we can say the full outer join is an union operation between left outer join and right outer join, right? So hope you understood this join concept in relational algebra of DBMS. So let's stop here, and if you are having any doubts regarding these joins, so feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.